We hear constantly about the AI boom, the innovation, the speed, the massive technological leap forward. It sounds like just pure, unrestricted growth.
Hmm.
But our deep dive today reveals a fascinating paradox. The explosive energy driving this AI revolution is also creating a new, really intense chip shortage crisis.
And it's reshaping the entire global semiconductor landscape.
Exactly.
That's the absolutely crucial context we need to establish for you right now. The sources are definitive. This is not the sort of, temporary supply chain hiccup we've dealt with
Yeah,
before.
right.
This is a transformative shift.
Yeah.
The AI supercycle is fundamentally rerouting the world's most critical manufacturing resources.
And that hits the industries that rely on stability.
It does, specifically automotive manufacturing and consumer electronics. They're facing intense structural pressure, and it's happening globally.
Okay, so our mission in this deep dive is to shortcut you straight to understanding the mechanics of this shift. We need to rapidly unpack how this demand is diverting resources, creating these global tensions, and impacting everything from your phone to a new car.
And we're going to go through these source documents sequentially to get the full picture.
Let's do it. We're starting right now with the colossal scale of the AI supercycle itself.
So when we talk about scale,
We aren't talking about marginal growth here, are we? The source material projects that sales of dedicated AI chips are going to surge past. What is it?
$150 billion in 2025.
Wow. $150 billion. That is a dizzying amount of capital.
And it's fueled almost entirely by generative AI and the colossal build-out of data centers.
So all that financial momentum is concentrating power very, very quickly.
Right, and what's crucial to understand here is that these new AI accelerators,
Hmm.
they aren't just slightly better chips, they're fundamentally different
That's right, in what way?
in complexity, in cost, and in the resources needed to build them. And this complexity has allowed NVIDIA to cement itself as the undisputed leader. They now command over 70% of the advanced packaging capacity at TSMC.
Hold on, let's pause on that. 70% of capacity at the world's premier manufacturer.
70%, yes.
That's an extraordinary concentration of physical production. What does that even mean for everyone else, for anyone trying to innovate or even just make basic server chips?
It means they're competing for scraps. The consequence is immediate. These AI chip giants are reserving production capacity years in advance.
So they're effectively pricing or just locking smaller players out of the market entirely.
That's it. So even though we hear about all these massive fab expansions, the announcements about new multi-billion-dollar facilities being built,
Right.
the demand for these cutting-edge processors continues to outstrip the supply that's actually available right now.
So this is a signal that this shortage isn't temporary.
It's prolonged, and the winners are taking an overwhelming share of the physical manufacturing output.
It sounds like the gravitational pull of AI is so strong that it's literally bending the entire supply chain toward its own needs.
That gravity creates a massive ripple effect, and this is where it gets really critical for anyone making traditional electronics.
Okay.
The pressure doesn't stop with the super advanced AI chips. It hits the most foundational components in the tech ecosystem. Standard DRAM chips.
The memory used everywhere in your PC, your phone, traditional server.
Exactly.
That's fascinating. Why would the demand for these really specialized AI chips affect something so commonplace as standard computer memory?
It all comes down to manufacturing prioritization. The huge surge in demand for specialized HBM, that's high bandwidth memory.
The ultra-fast memory that's stacked right on the AI GPU.
Right. That demand is directly diverting production capacity away from standard DRAM. They use similar foundational manufacturing lines, but HBM is exponentially more complex and, frankly, more profitable.
So manufacturers are naturally prioritizing the lucrative, highly complex stuff over the standard workhorse memory needed for, everyone else.
Of course.
And the market's reaction to this diversion has been, well, violent, hasn't it? Let's put some numbers on the panic.
The statistics are, frankly, alarming. In response to manufacturers desperately trying to secure inventory, companies like Samsung raised their standard memory chip prices by up to 60%.
60, not 60%. That is not just gradual inflation.
Not at all. And what's more, the spot market for DRAM saw prices nearly triple year over year.
A 3x surge.
A 3x surge. That tells you everything you need to know about the level of scarcity and urgency in the market.
And when you look at inventory levels, you can see the stability just collapsing. The sources show inventory plummeted from a reasonably safe 31 weeks of supply.
Almost half a year.
Right, half a year of cushion, and it dropped down to just 8 weeks projected for 2025.
And that reduction from a 6-month cushion down to 2,
Uh,
that is what's triggering widespread market disruption.
Panic buying.
Immediate panic buying and strategic stockpiling. Companies are hoarding whatever supply they can secure. And the critical consequence here is that this behavior totally distorts the true demand signals.
So analysts can't tell how much is real consumer need versus just defensive hoarding.
Exactly. It creates a spiral of scarcity driven by fear.
Okay, so if the AI gravitational pull affects basic memory chips, how on earth does this affect the car industry? Cars, after all, they don't use those $150 billion AI chips.
They don't need the cutting edge, no.
Yeah.
But they rely heavily on what we call mature node semiconductors.
Older chips.
Older, less complex chips needed for fundamental vehicle operations. Think power management, sensor control, infotainment, essential safety systems like airbags. They're less glamorous, but absolutely mission critical.
And the sources show that these mature node chips are now being diverted. How does the AI ecosystem specifically siphon resources away from these, seemingly unrelated legacy chips?
Because the AI supply chain isn't just about the GPU itself. To run an AI data center, you need this enormous ecosystem of components. Power regulators, network interface cards, power delivery modules. Many of those supporting components, while they're not AI chips, they rely on mature node semiconductors.
Ah, I see. So the sheer scale of the AI build-out means a massive diversion of those older resources into AI infrastructure and away from traditional users like automakers.
Precisely.
And this brings up that historical context. Automakers were already vulnerable. We saw this early in the pandemic when they made that strategic miscalculation, canceling bulk orders.
They assumed demand would drop.
Right, and when it rebounded, they were left exposed. And that vulnerability persists today, now amplified by this AI-driven diversion.
Exactly. And the consequence is clear and visible to you, to consumers. These ongoing shortages continue to delay vehicle manufacturing, extending wait times significantly.
And just like with memory, scarcity drives up costs.
Which means higher prices for new cars and trucks.
So we have this massive gravitational demand from AI, creating ripples across memory and legacy chips. When we step back, what does this tell us about the structural fragility of the whole global semiconductor supply chain?
It exposes an incredibly dangerous level of concentration. Over 90% of advanced AI chip manufacturing is controlled by just 3 dominant players.
And each specializes in a different crucial step.
Yes. You have TSMC dominating fabrication, the physical chip manufacturing. Then Samsung leads in advanced memory, especially HBM. And of course, NVIDIA holds the monopoly on the high-end design and architecture.
That kind of tri-monopoly creates a single point of failure. If one of those 3 players hits a constraint, the entire AI supercycle just stalls.
It does. And our sources point to very specific constraints compounding this risk. The first one is geopolitical.
Export controls, trade restrictions.
These are creating artificial but very real bottlenecks. The second is just basic raw material scarcity, silicon carbide, rare earth elements, things you need for long-term production.
But the most technical and maybe the most crucial physical constraint right now is packaging. Specifically, the shortage of CoWoS substrates. Could you unpack what those are?
Sure. CoWoS stands for chip on wafer on substrate.
Okay.
Think of it as this highly complex, specialized base.
Yeah.
A platform that allows multiple chips, like the powerful AI GPU in those fast HBM memory stacks, to be interconnected and function as one single, extremely powerful unit.
So it's the thing that holds it all together.
It is. This process, called advanced packaging, is the final physical step, and it's as incredibly difficult and capacity limited. Since every high-end AI chip relies on CoWoS to function efficiently, the shortage of these substrates acts as a hard cap on how many AI chips can be produced.
Regardless of how many silicon wafers TSMC can churn out.
Exactly. This single constraint is the immediate throttle on AI supply.
Wow.
And while we spend a lot of time discussing hardware constraints, fabs, substrates, raw materials, we cannot overlook the talent crisis.
The human element.
Yes. The shortage of qualified personnel is an equally, if not more, critical challenge. Building and running these advanced facilities, it requires highly specialized, often PhD-level expertise.
And that kind of human capital can't be developed quickly?
No, money alone cannot solve it.
The numbers here are sobering. The source material estimates the industry needs 1 million additional skilled workers globally by 2030.
A million.
That skills gap lacking enough engineers and cleanroom technicians is actively slowing down facility ramp-ups and innovation. It's a bottleneck at the human level.
It is.
But look at the sheer contrast in capital expenditure. We see big tech Alphabet, Amazon, Meta, Microsoft. They're investing a staggering $400 billion in AI infrastructure during 2025.
According to Morgan Stanley, yes. A huge financial commitment.
So that raises the question, if $400 billion is pouring into infrastructure, why are we talking about worsening shortages and record high prices?
Because that money is intensifying the competition for the limited existing supply of both the chips and the limited supply of specialized human talent. The capital is chasing scarcity.
And we see that intensity reflected directly in market pricing. Samsung's dramatic 60% memory chip price increase, that is a very loud market signal.
It signals severe constraint and surging profitability. This patterned massive investment leading to aggressive competition and price hikes is likely to spread across the entire industry.
Squeezing out any player who can't pay the premium.
Absolutely.
Okay, let's tie this entire structural shift back to you, the listener. If you're a consumer or you're running a business, what are the inevitable widespread economic impacts of all this?
Well, the source material is very clear about the flow-through cost. When memory chips surge by 60%, those price increases are not absorbed by manufacturers.
No, they get passed on.
They flow directly through to the end products. That means your next car, your new smartphone, business PCs, enterprise servers, they will all carry a higher cost burden. Inflationary pressure from this is basically locked in.
And we also see a distortion of innovation. The resources, the capacity, the talent, it's all focused squarely on AI.
Which means product launch delays are highly likely in sectors outside that core AI ecosystem.
So manufacturers of, say, standard electronics are going to struggle to get the components they need to iterate and bring new products to market.
It effectively slows down technological progress in non-AI fields.
Wow.
And critically, this creates severe competitive distortion. Companies with enormous balance sheets and existing long-term contracts for chip capacity, like those big tech firms, will gain insurmountable advantages.
Over smaller competitors.
Right. Meanwhile, consumer electronics makers face a perfect storm. Higher chip costs, margin pressure, and major supply chain risks. It's an incredibly difficult environment for smaller players to survive, let alone thrive.
So wrapping this up.
Our deep dive reveals a fundamental truth. The AI boom isn't just generating wealth, it's creating profound structural imbalances. Because advanced chips are so exponentially more lucrative, the necessary resources, from CoWoS substrates to basic power management chips, are inevitably drawn away from traditional markets.
This structural instability is the core reality.
It's the new reality facing global tech.
So to navigate this, stakeholders have to act strategically right now. The source material suggests a few things. First, dedicated efforts to diversify supply chains.
Both geographic and supplier diversification to build resilience.
Second, they must urgently invest in talent. We talked about this. Massive, sustained workforce development programs are essential. Hardware means nothing without the skilled people.
And third,
Leaders must act strategically, now to consciously balance the explosive growth of AI with the critical foundational needs of other sectors like automotive and global electronics.
it's about managing for overall technological stability.
Which leaves us with a really important question for you to consider.
If all this financial capital is flowing overwhelmingly toward AI infrastructure and these ambitious technological goals,
Right.
but the true limiting factors are the slow-to-develop skilled human capital and the finite supply of basic raw materials. How long until those foundational earthly constraints completely overwhelm the technological ambition of the AI supercycle? It's something for you to mull over as you see prices change in the marketplace and maybe products don't arrive quite as quickly as they used to.
Food for thought indeed. That wraps up this crucial deep dive into the AI-driven chip crisis. We encourage you to keep exploring these critical dynamics.